So welcome to PyOhio. My name is Preston. I'm a developer evangelist with Cisco's DevNet organization. If you're not familiar with DevNet, odds are good you've probably at least heard of Cisco. And DevNet is Cisco's developer enablement program. So nearly everything Cisco has these days has APIs and are programmable. And up on DevNet, you can find all the APIs and sample code and things for that. And in today's talk, I want to spend a little bit of time talking about some of the useful Python libraries for network engineers to be comfortable with for all sorts of different topics as we go through on that. And so the areas that we're going to go through is kind of in 4 chunks. We're going to start out with some libraries to help you work with data that you might come across as you kind of start to embrace programmability as a network engineer. So we'll talk about working with JSON, XML, and YAML. By and large, many of us are still managing elements of our networks with CSV files or Excel spreadsheets. So how can we import in that information from an Excel spreadsheet or in from a CSV and work with it in our Python code? And then Yang, which is a new standard from the IETF, for describing data models for networking pieces. And we can work with those inside of Python. So we'll hit that piece. And then we're going to talk about API libraries, right? If we're using Python to manipulate our network, we need to connect over some sort of an API. Maybe that's a new API like REST or NETCONF, or you have to leverage some of the traditional APIs and interfaces like CLI and SNMP. And we can work with all of those inside of our Python code as well. The most of our talk today will be in those areas, and then at the end we'll spend a little bit of time introducing other topics that are there. And so in configuration management, the idea here is rather than talking one device at a time, writing code directly to an individual device's interface, we want to leverage a program to actually manage the entire configurations. We'll talk about some of the examples of those that are available in Python. And then at the end, a couple of handful pieces that are out there that are also useful to understand and kind of that you can tackle as you go in. All of the code samples that we're going to look at are all up on GitHub, and I've got the link for that available. And these slides are posted on SlideShare, and I'll send the link and try to get it added into the PyOhio description for the event as well. So let's jump right in with libraries to work with data. Now, we work with different types of data day-to-day as our network jobs go through or in any type of IT. And so we're going to hit these pieces. XML, extensible markup language, kind of HTML for data transfer. I don't know anybody that really loves XML, but it's all over the place. And so we need to figure out how we can work with that inside of our programs. And we'll talk about a library that I tend to always go back to, which is XML to Dict. Python has an XML library that's built into it, and that's fantastic. And it's super powerful for crawling the tree and making manipulation. But frankly, using the native one is a bit tougher when all I really want to do is turn that XML into a dictionary that I can easily use. And that's what the XML to Dict library is handy for. With JSON and YAML, we've got libraries that can do similar aspects on that. And then we'll look at the CSV library that's included with Python so that we can manipulate and work with our CSV files. And then finally, the Yang that we can go through on that. So we'll start out with XML. As I mentioned, our goal, or my goal, whenever I'm working with data inside of Python is to, as quickly as possible, turn this into a data structure inside of Python that I can use and manipulate really easy. And that always comes back to a Python dictionary. And the XML to Dict library lets you do that fairly quickly. And so it lets us take our XML data and turn it into a dictionary, or technically an ordered dictionary, because when we want to go back to XML, the order will be really important as far as the XML schema goes. And then we can use functions to parse and unparse. Now these are some of the examples. We're not just going to look at it in a slide. Let's actually see some of these things in live action. And so the XML file that we're going to look at is here. And so it's a basic description of an interface represented in XML. And now we'll see that same interface information in the examples for JSON and YAML as well. And so the code that we're going to run is here. And I'm going to do this in a Python interpreter so we can talk about each step along the way. So our first step with any of these is going to go ahead and import in XML to Dict. That's the library that we'll use. I've already pip installed this at this point. And then what we'll go ahead and we'll run is this with open command. And so that XML file that we were looking at is stored as a file on my system here. I may have gotten that XML from an API call from a practical purpose, but now it's there. And I can see that we've got access to it by printing it out. And so there's just the raw string. If I look at the type of that data, XML example, we can see that it is a string because that's all XML starts out with. Now our goal is to make that something that we can parse and work with, and this is where the XML to Dict library will come in really helpful. By passing that through the parse function, now if I look at the type of XML Dict, we can see I now have an ordered dictionary, which means I can quickly get access to some of the pieces in there by using typical dictionary syntax. So passing in, I'm looking for the interfaces key, and then underneath the interfaces, I'm looking for the name. And now I can do anything I want with that, such as just print it out or make use of it. So there's the Gigabit Ethernet 2. Very quick and easy to dive inside of that XML and get access to the information I'm interested in. Now, what if I'm trying to manipulate the data that's there? And so I can change the IP address. I'll scroll over a little bit. All I'm doing is resetting the IP address that's stored inside of this dictionary to a new one. Let's say my goal here is to actually re-IP an interface on my router or my switch. I've now changed this in the dictionary inside of Python, and now I want to send this back to a device in the native XML that it started. I can do that again with the XML to Dict library and using the unparse command, and now I've reverted it back to an XML string that I could send as a package with whatever API that I'm after. And that's often what we're trying to do with data in this fashion. Bring it into our Python code, turn it into something that we can work with, and then turn it back into the native syntax, the data format, and send it off. And that's how we can do it very easily using the XML to Dict library that's in there. XML is useful, and we have to understand it because one of the main networking standard interfaces today is NETCONF, and it relies on XML under the hood. But frankly, I usually try to get away from XML as fast as possible, and so now we're going to talk about how we can do the same thing with JSON. And so with JSON, we do have the benefit of a built-in JSON library inside of Python. And this gives us the ability to take advantage of the core library that's there to take the same activities. We can use JSON.loads or load string to read in a JSON string and turn that into our Python dictionary objects that we're after, and then dumps will go back. If we look at this one live, so there's our JSON example, the JSON example, and we're going to do the same thing that we just did with the XML. So my cheat sheet here, so I don't have to type completely off the cuff, is we'll start out again with importing JSON. That brings it into the Python interpreter. And then from there, we will go ahead and use with open, and now I've read in the string. So just to see that we have the string, there's that same string of JSON data, but it is just a string. We'll use this JSON.loads function to turn that into our dictionary. And so now, we have a dictionary object. So in this case, with JSON, we don't have to care as much about the order. That data format is order agnostic as long as the syntax is there. And so we can run through the same steps. I can reach into that JSON blob and get access to the actual interface name that I'm interested in. I can change the IP address, and in this case, the code is nearly the same as what we saw with the XML as we go through, and then convert it back into JSON. Now, the key part of this is the process that we did, other than the parsing using the JSON.loads and the dumps, which turns it back into JSON. Those are the only things that are different between whether it's XML or, in this case, JSON format. Because my goal is always to get it into a native Python object that I can manipulate in the same fashion that goes through. Now, one of the data formats that's starting to show up for me more and more often with the different programs and protocols I'm using is YAML. Yet another markup language, or whatever you want to say those letters stand for. And in this case, we've got the PyYAML library, which was modeled very heavily against the JSON library that comes with Python. And so I can load, no S at the end of this one, to read in a YAML data format. And then to convert it back, it would be dump to turn it back out there. Now, if you've never seen YAML as a data format, we can take a look at it here. It's a very simple to read data format. It almost looks so simple that you would never believe that that's an easily parsable data format for programming, but it really is. One of the reasons YAML's become so popular as a data format is because it's so easy to be both human readable as well as parsable by our computer programs, whether that's Python or something else. And the way that the format works is by indentation and key characters like this dash symbol that indicates a list. And so these are simply key value pairs that go through. Now, the challenge with YAML is that because it is so indent and white space sensitive, it can be a challenge to kind of keep it in format, but it is a very nice text, or a very nice data format to work with. And so if we go ahead and we take a look at our code to go through on this case, so I'll switch back. All right. And so we'll take the first steps that we've done before. So we'll import YAML, and then I'm going to read in that YAML example file. And if I look at the type of YAML example, we can see that it starts out as a string, like all the rest of these have. And the goal is to turn that string into, we'll print it out too. So there's the native string, and I can use the YAML.load to go ahead and turn that into a dictionary. So type YAML dict. And so now I have a Python dictionary, and the rest of our process is exactly as we've seen it before with XML and JSON. And so I can go ahead and reach in and grab the interface name. I can make a change to the IP address, and then I can return it back into its native YAML format. And so now I have the choice. I can work with XML or JSON or YAML, and I can use the same types of Python language no matter what type of data format it comes through. And this should be our goal as we process and work with anything inside of Python, is read it in, process it, and then at the very last minute convert it back to whatever the required formats are. Now the next piece I want to talk about is not the data formats we might be working with information, it's just kind of the nature of the game inside of the network or IT in general, is that we store information about our environments in Excel spreadsheets or CSV files, and so we may need to read that in. And the native CSV library with Python is very easy to make this type of activity. My common use case here is I have a list of routers or switches, and I need to read them in and go take some action on every one of those devices that's there. And the CSV library will let us do that by creating an efficient reader object. Now, in production, most of my CSV files might be huge, hundreds or thousands of lines. And one of the things that's nice about the CSV library is it'll handle the memory issues, because it doesn't have to read the entire file in all at once. It can do it one row at a time to be a very efficient function as it goes through. So if we look at this one, so our CSV data is here. And so it's a very simple 3-row. So I've got 3 routers with a name, an IP address, and then the location that's there. So we could have that same type of format with what we're trying to go after. And then the function we're going to run is here. And so we're going to import in our CSV. And then I will open and then read out just to show that we are accessing that same CSV file. So there's my 3 routers. Now the way that the CSV library works is we don't work off of the string format like we did with the XML and the JSON libraries. We actually work on it as a file object, 1 row at a time. And so we start out by reopening up the text file using the withopen command, and then we'll use the CSV reader to actually create the CSV object that we can then manipulate and loop over with our for loop. Inside of each row, all I'm going to do is just print out the information. But normally you would use this to connect off to your device, make a configuration change. Whatever you needed to do to those devices, you would do inside of that for loop. And then because I'm in an interpreter, I can't do these one line at a time. It kind of has to process all at once. So let's go ahead and run these all together. And then run it. And we can see I've then, so it opened up the file, created the CSV reader object, looped over them, and then printed out, just in this string, router 1 is in New York and has IP address. So again, I can manipulate and do whatever I need to with the data after I've made the action on that. The CSV library lets us handle complex CSV files and Excel spreadsheets with and without headers, just based on indexes. It's definitely a library that you want to become comfortable with. Now the last data format one I want to talk about here is around Yang. Now Yang is a standard for writing data model language. It's a data modeling language standard. And you can use Yang to create data models for anything, but it's most commonly used to create models for network objects, things like an interface or an access control list, a routing protocol definition. And so the Yang language looks like this, and this is a very simplified example. Now, as a network operator, you're likely not going to work with the Yang language because you're not writing data models. What you want to do is actually consume the data model and retrieve information from that. And that's where the pyang library will come in for us. It's a Python library, but it's also a command line utility for reading and processing these Yang files. And we can use pyang to print out and reformat the native Yang language into a much more friendly format to go through. So I have a handful of examples here. We'll run a couple of these to kind of see how they go through. So if I switch over again. All right. And so to start out with, I've got a handful of different Yang models. And so this file here on the side, this is the native Yang definition from the IETF for a network interface. And it is hundreds of lines long, and it's very complex. As an operator, I don't want to ever look at this file if I can avoid it. And so what we'll use is we'll use some of these examples that are there. And so the first thing I want to do is I want to process and display that Yang model in a fashion that's easier to read. And so believe it or not, this is the easier to read version. And if I look at this, this shows me that each interface, I've got an interfaces collection that will have a list of interfaces. Every interface has a name, a description, a type, an enabled status. This is much simpler to look at than that native Yang language to look through. Now the Pyang library, this model is actually fairly simple, but some of these get quite long. So maybe I'm only interested in the configurable elements, those things that are labeled RW. That means they're read-write. I can configure them. I can modify that Pyang command a little bit and say in addition to ftree, so that says formatted as a tree, that's what we're just looking at there, I can say tree path, zoom in just to the interfaces bit of that information. And so by running that command, it just shows me the part of the Yang model that I'm interested in. So I can zoom in and really target it. And so now I can see the types of data that the name is a string, we can see the Boolean value for the enabled status that's there. And I can use that Pyang library with all of these different commands to kind of dive in and manipulate and understand what's there. The other handy one is the way that most of us are using these data models is actually with NETCONF to connect to a device and retrieve information about our device. And then we'll have to process that in Python. Now if I run this command, which rather than doing the formatting as a tree, I'm going to format it as an XML skeleton. What this says is, show me what the XML version of this data would look like as it comes back. And so now Pyang will actually give me an output that I could put through my XML Python script to understand how would it process, what can I expect to work with. And I don't even need an actual device to use. I can just use the Pyang library to go through. Being comfortable with manipulating and working with the Yang libraries is going to be critical as NETCONF and these other standards become more common to go through. So with that, now that we've talked about how we can work with the data, let's talk a little bit about the API libraries that will actually connect with our devices. And there are 4 different libraries and interfaces I want to go through. We start out with REST APIs. Now REST APIs run over the HTTP protocol, and if you're doing anything in Python with HTTP, everybody, or at least everybody I've ever talked to, tells you to use the requests library, because it is the easiest one to really kind of get access to that data. And so we'll talk about the request library for that. I've mentioned NETCONF a few times. It's the new standard for device interfaces from the IETF to connect, and it kind of replaces the SNMP protocol. It's the next generation of that. And so NC client gives us the ability to use NETCONF instead of Python. And then if you do have an older device that only has CLI, we've got some libraries such as NetMiko to work with there. And then occasionally we do want to use SNMP, so we can go through them. So we'll start out with our REST APIs. Request is a full HTTP client written in Python. Now what types of REST APIs might you be working with? Well, we do have RESTCONF. RESTCONF is the REST API version of NETCONF for those of us that want that. It is a very new standard, so not all devices support that yet, but support is increasing. Now many devices do have native REST APIs, and so there may be something that's not a standard REST API, but you can still use REST to connect and manipulate those devices. And then some of the first REST APIs or HTTP APIs that networks started to offer were JSON RPC, where you basically wrapped up a CLI command inside of a JSON blob and sent it off over HTTP. Any of these can be used with requests to make those commands that go through. In our first example here, we're going to see how we can retrieve configuration information using the RESTCONF protocol and the requests library. So here's the code. We'll run it in a second, but we'll talk through it. We start out by importing requests in YAML. Now I'm importing YAML because this first block is going to actually import in all of my device inventory information. I don't want to put the IP addresses of all of my devices in the Python code. I'll store that in a data format, an external file, in this case a YAML file. and read it in using that same YAML.load that we just talked about. Once I've got that, now I set up my request connection. This is an HTTP protocol, so I set up my headers, I set up my base of my port, so it's going to be HTTPS. I have to put in the IP address of the device. We'll get that from our YAML file. And then RESTCONF starts at RESTCONF data. And then for interface configuration, we'll target interfaces, and then interface, and then which specific interface are we after? This is just like using any other REST API to connect to a device. Down here, we finish completing our URL by combining in the IP address and the specific interface we're interested in this case, Gigabit Ethernet 2, and then using request.get to fire it off. Fairly straightforward if you've done any REST API work. And then finally, we're going to print out the information. We're going to print it twice. First, we'll just do the raw text that comes back so that we can see the raw format. And then we'll process it and print it out in a nice fashion. I'll switch over. All right, so in here, I have my RESTCONF example. So we'll run Python RESTCONF example 1. So this is that code we just looked at, and it ran pretty quickly. Yay. So this first block is what the raw REST API came back with, and it came back in JSON. We just finished talking about how we can process the JSON using our libraries. And then down here at the very bottom, we can see the interface Gigabit Ethernet 2 has IP address of the IP and goes through. Now I may need to change the IP and do those other pieces. We can do all of that with this API in the library that's there. But we can see how easy it is to manipulate our devices that have a REST API using these libraries. Now RESTCONF is a brand new API and interface for devices. Many devices are still lacking support for it. But NETCONF has been around for about a decade. So most of our modern operating systems in the network and platforms support NETCONF. And so becoming comfortable with using it is a good skill to pick up. Now with NETCONF inside of Python, NC client will be your friend. It handles all of the session establishment. So NETCONF runs over the top of SSH. And so with NC client, we don't have to worry about negotiating the SSH pieces, handling the encryption. It handles all that for us. It also takes care of all of the RPC wrappers and the raw XML processing to send and retrieve the information that's there. And so with NETCONF and NC client, we can tackle the same example we just saw, retrieving configuration details, but this time with NETCONF. So we'll start out like any Python program, importing in our file. So we'll import in NC client and then manager. Manager is the client side that we'll use for NETCONF. And then we'll see I'm importing an XML.dom import mini-dom. That's the native XML from Python. And the reason I'm using it here is so that I can quickly print out the XML data that comes back in a pretty fashion. But the actual processing is going to be done with that XML to Dict library that we talked about before. Inside of here, the first step is to create the filter. So with RESTCONF, I just used a URL to target a very specific interface. With NETCONF, we actually send it an XML payload that has that interface name that we're interested in. So this is the equivalent of the URL that we use to target an interface, but done inside of XML. Once that's created, we then go ahead and open up our connection. So with manager.connect, that connects to our device over NETCONF and gives us a variable M here at the end that represents our open connection. We can then go ahead and connect together our interface name we're interested in, again, Gigabit Ethernet 2, with the filter that we created, and then use, where is it? There it is, m.getConfig, that's the NETCONF operation we're going to send, to retrieve from the running configuration our interface information, print it out with the XML to dict.parse so we can get our details, and then print it to the string. So the result is basically the same thing we did with RESTCONF, but now doing it with this other protocol that's there. We take a look at this example. NETCONF example 1. This will run. There we go. I'll make this a little wider so we can see the XML better. That's probably close enough. All right. So the first thing it prints out here is the raw XML that came back. And so what we can see is this is the actual XML that came through. And it represents the exact same interface configuration that we saw with RESTCONF, but now it's an XML instead of JSON. And then down at the bottom, it prints out the exact same piece. This is another important element for network engineers to recognize. I can accomplish the same task, getting configuration information from my device over multiple protocols to go through. Usually, as an engineer, we just pick the protocol that we are most comfortable with and the libraries that are available if they're all available. The platform we're using here happens to support both, so we can take the same action that's there. Now, what if your platform doesn't support one of these newer interfaces? This is where the CLI still continues to be important for us. Many of our organizations have wide networks that are deployed that you may not have upgraded in a while, don't have budget to increase, but that can't prevent your automation strategies and programmability strategies. And this is where the CLI can continue to be a programmable interface. And NetMiko is a great Python library if the CLI is the interface of your choice. Now, NetMiko is built on top of a common Python library called Paramiko for establishing SSH and Telnet types of connections. But what's nice about NetMiko is it has knowledge about network devices. And so there's drivers for Cisco and Arista and Juniper devices so that you can connect in. It knows what config mode is. It knows how to process against the device. And so it takes care of a lot of those pieces for us. And then with NetMiko, we can do the exact same thing that we've done with the other interfaces. But there are some challenges that go through, because when you're working with CLI, it's clear text that we're dealing with. And so in this case, we start out with importing in NetMiko, and then my bane of my existence usually, RE, that's regular expressions, because I have to parse this text. I don't have the easy way to turn CLI into a dictionary, so I have to figure out how to get it out myself. And so we open up the same thing we've done before. This is that YAML file, so I can get the IP address of my network device. And then I'm adding in the device type as Cisco iOS. This platform is there. The NetMiko library uses that bit of information so it knows how to establish the connection with the device that's there. Then we go ahead and create, what are we going to send it? We're going to send it a show running config interface and then some particular interface we're interested in. So that's the template of the command we want to send. Our next step's actually pretty easy. We open up what's called a connection handler. That'll establish the CLI connection to our network device, over which we can send as many commands as we want. And then we create our final actual configuration send, which is going to just insert gigabit Ethernet 2 in. And then we send that off using ch.send command. And then the first bit is easy. Just print out what comes back. And that'll be the raw commands that come back from the device. This next slide is the hard part. What we get back is clear text. And so now we have to figure out how to go into that clear text and get what we're after. And so here is probably the simplest regular expressions I've ever written for this, but it kind of shows what we have to do. We're going to get back something that starts out with interface. The interface name is going to be after that. And so I go grab that, and I can turn that into the interface name, a name variable. I can get the description out of the piece by looking for description, and then anything that comes after that. The IP address and net mask, those come together on the same line, so I have to group those out. If I actually push this into some sort of production system, my guess is that those regular expressions would fail me at some point, because that's kind of how regedge works. But for my basic demo, it works pretty good. I save that information out, and then I can print it in the same type of a format. CLI is an easy one for us as network engineers to go back to, because we're super comfortable with the interface. But to continue to use CLI inside of Python, now you also have to become a regex expert. And that's far more challenging than simply learning something like RESTCONF or NETCONF and these other interfaces that are there. But we can see this one in action as well. And so cd. So if I run Miko example 1, so the same thing, we're trying to get the gigabit Ethernet 2 information. This one takes a bit longer because it's processing all of the CLI commands on the back end. But it should come back. There it goes. And gives us our piece. So this bit of context, if you've ever worked on a Cisco device and run a show run before, it probably looks familiar, because this is exactly what it would show you on the screen. This is what came back from NetMiko. And I had to parse all of this information so that I could simply get the name and IP address of the information and put it out. Now, if you have to, it's awesome that we have libraries like NetMiko to do this. But you should always be looking for, is there another interface? Can I use NetConf? If I've got a piece of hardware that doesn't have it, is there a software that you can load up that gives you some of these new interfaces that you can use? Because the benefit of having those programmable interfaces comes because you don't have to work with as much of this regular expressions or parsing or slicing that goes in. Now, the last interface that you're probably still familiar with and may be asking yourself, what do I do if I need SNMP information through the devices? Now, I did an informal poll fairly recently because I was curious how many network engineers that were diving into automation, writing their own scripts, were still using SNMP. And the unscientific answer was not too many. Most of us are actually trying to move away from SNMP, but that does come up occasionally as we go through. And if you're writing your own code and you need SNMP for a trap or some other piece of information, PySNMP is where you want to start. This is another Python library that lets you interface with both traps as well as queries inside of SNMP. And you can go through and check it out. Now, I'll be honest, it was probably the most difficult library for me to fully figure out how to go through, and I encourage looking at the examples that the PySNMP people provide if you need to use it, because they'll look an awful lot like the code that you're looking at here, because I used a lot of their examples for it. And we start out like anything. We import in PySNMP, HLAPI, that's what we're going to go ahead and connect to, and then our YAML library, again, so we can read in the device information that we're after. And in this case, in addition to the IP address, I've got my read-only and my read-write communities. And for my demo, I'm just using public and private for those. Now, once we've got those in, this is where the actual PySNMP comes through. We start out with iterator, get command. And then this is the block that's actually going to make the connection off over SNMP. We pass in a bunch of information. We pass it the community data, so what community we're interested in this case, RO community, so that was public. The IP address of our device, and then the port. So 161 is our standard port, so we're connecting with that. Context data is to grab the information we're after. And then this is the particular MIB that I targeted, which is just a generic system description MIB that's there. Now that creates what's called an iterator object. And so we send it across next, which basically says, give me the next piece of information that this SNMP connection had. And that provides back 4 pieces of detail that you have to deal with. Now, 3 of them relate to errors, because SNMP apparently, they expect a lot of errors. They throw them right up there. And so we get error indication, error status, and error index. Then finally, we get the var binds. That's where the actual data that we're interested in comes through. And then it seems like a bit of boilerplate code that they recommend, which just does an if. Was there an error? If there was, print out what it was. Is there a status about error? If so, print that out. And if not, then go ahead and just print out what came through. So this gives us the ability to process through SNMP. After going through this, I realized why many of us are looking for alternatives to SNMP as we do our automation skill sets. But I did get it to work, so let's go ahead and run it. And so here, this one actually runs really quickly, because SNMP is an efficient protocol. I'll make it a little wider so it's easier to see. And so this is just printing out the basic system description from the device we connected to. It's a Cisco iOS device. It's running version 16.7. And then we can see some of the tech support information. Using that same basic code, I could target any MIB as long as I knew what one I was after and I could pull them through. Now, the one great use case I actually talked to one of the partners I talked to is they've used PySNMP not for this type, but to actually build custom trap receivers so they can take actions based on it. I looked at their code. I didn't understand most of what was in there, but I was pretty impressed with what they were able to actually construct. But it is there if you need to dive into it. All right. So let's move along and talk about the next generation of kind of tools. We started out with going through data formats. Like, what are the types of things that we can do? How do we manipulate the data that we have to work with? And then we talked about different libraries to directly program the interfaces that are in our devices. Now, the next step up from that, and what many of our organizations and enterprise customers I talk to is, that's great. I can do a lot with Python, but that's a lot of Python to write, which is where tools like these configuration management solutions, because you can leverage other people's code. And the idea here is rather than writing your own Python, leverage a tool or a library that abstracts a lot of it. And there are 4 of these inside of Python that I think are worth knowing exist and are out there. I've broken them into 2 basic categories. The first one here are Napalm and Nornir. Now, these are network automation frameworks that were designed initially to be network automation frameworks. The people that wrote them were network engineers. They were designed around networking concepts. And they're fantastic, and this one's very new. This one's been around for a long time. The folks at Spotify built Napalm originally, and then some of them have continued to extend it in some of these other areas. Now, there's also tools that were originally designed for server automation. So Ansible and Salt are two configuration management tools kind of in the DevOps space that originally were designed to manage fleets of Linux servers that have started to be ported over for network automation and network management. Inside of that bucket are also tools like Puppet and Chef. Those are written in Ruby, which is why they didn't make it onto my Python slide. Now, Ansible and Salt are fantastic tools for doing these pieces, but all of the network automation has kind of been added after the fact. And so there are some interesting pieces about working with those tools in your network that you have to just kind of address. That's why some people go back to Napalm and Nornir, because those were designed specifically for network automation, but they provide the value. We're going to talk about the two most common ones I run across a little bit more, Napalm and Ansible. So first with Napalm, this is a very mature Python library. It was originally designed by the folks over at Spotify to help manage their multi-vendor network that was out there, and it's super powerful. It allows you to do configuration replacing, merging your configs, comparing, doing transactions roll in and roll out as it goes through. It is a full-featured network automation framework that goes in. What's nice about Napalm is they built all of these capabilities on top of drivers for different devices that existed. And so if your network is made up of Juniper and Cisco and maybe a couple of different versions of Cisco software, you can use Napalm to kind of abstract and deal with them all in the same type of a fashion. Because each of the libraries there are under the hood. So we're using NetMiko to connect with CLI to some of the devices. We're using some of the specific libraries that are available from the other vendors to connect to those devices. This gives us the ability to kind of just specify the driver for the device and then whatever types of configuration we're after as we go through. If we want to manage our entire configuration at once, so I tend to call this infrastructure as code. If somebody goes into my network infrastructure and starts manually making configuration changes, we consider that bad. And we want to make sure that the configuration always looks exactly like what we want. You want to use a replace, which basically says this is the config it should be. Go ahead and make sure this is on there. If you're just trying to add and make sure that the configuration you're interested in does exist, but you're not as interested in the other stuff that might be there, that's where merge capabilities are like. You can say, hey, add this piece of configuration into the device and make that available as it goes through. That's a helpful case to go in as well. Napalm can also be used and integrated with other tools. And so if you're using Ansible to do your infrastructure management across your entire data center, you can actually use Ansible to call your Napalm pieces under the hood if you don't want to do it natively in Ansible. And then as I mentioned, Nornir is new, and I was actually surprised to see that Nornir, a lot of people just use it to call back to Napalm and build these tools together as they go through. Now on the Ansible side, Ansible is a leading DevOps management tool, and it's definitely the leading one in the network automation space. And there's a lot of reasons why Ansible has become so popular for network management and network automation. One of the reasons is that it's agentless. Now, if you're working with Puppet, Chef, or Salt, and you want to manage your network infrastructure, you have to put some Puppet, Chef, or Salt software on your switches and your routers. It's just how the architecture works. With Ansible, you don't need to do that. It will just communicate over whatever interfaces are there, CLI or NETCONF as it goes through. So the fact that we don't have to add things onto our routers and switches has made Ansible very popular in the area. Now, many network engineers are also learning Python, and because Ansible's written in Python, it's also had this kind of acceptance that went through. And then there's the fact of the reinforcement. Because a lot of people started out with Ansible for network automation, there's really good examples for it. And so because there's good examples, more people go use it, which generate more examples as we go through. So it's kind of this very much the strongest portfolio or platform and community around network automation. Ansible comes with a huge library of network modules for managing all sorts of vendors' equipment, switches, routers, firewalls, wireless devices. There's a lot that you can do using Ansible. So let's see an example of one of these. We'll take a look at Ansible that's being used to actually manage the demo environment that's here. Close a couple of these. So with Ansible, Ansible is written inside of Python. Like the Ansible program itself is written in Python, but as a consumer, most of us actually won't see and deal with the Python. What you're going to work with is actually YAML files. And so here, this is a YAML definition of how the automation to manage the network for my demos under the hood are used. And what we have is we've got this description inside of YAML of what we want to accomplish. So my core of my network, I need to configure the network interfaces, and I need to configure OSPF. My distribution, I need to add VLANs and other pieces that are there. And so the way that Ansible is written is this modular fashion. This is what I will run, but under the hood, we create things called roles. And it's in the roles definition where we actually talk about what we're trying to accomplish. So as an example, this is the Ansible definition of how we configure an interface on a Nexus device using the Nexus modules that are there. If I were to actually look at the netconf config.py file that does exist someplace in my virtual environment, I would see the Python code that took those actions. Now inside of here, all of these double curly braces represent variable substitution. We'll insert in information about a particular device, and all of the variables are actually stored inside of other YAML files that describe it. And so if we look here, we can see this is an example of the layer 3 interfaces that go on this particular device. And so all of this information gets merged together with those Ansible playbooks to actually make these configurations as they go through. And then on that side, let me see if I can get in, and we'll make a quick demo of how that goes through. Coding, oops. There we go. All right, there we go. Now I'm where I wanted to be. So inside of here, what I can go ahead and run is the actual Ansible playbook. This network deploy.yaml that I highlighted is the file that defines how we run that. And so if I do Ansible playbook, and we're going to, I'm just going to limit it down to one device. So we'll limit it to the core one. YAML. There we go. So what's nice about using these types of tools that go through is it actually abstracts a lot of the pieces and provides you useful feedback as it goes in. So this is running the Ansible playbook and it's processing. So it's inspected the device, seeing that this is a Cisco iOS device. It's constructing the configuration that's needed, and then pushing out all of the information using the Ansible modules that are under the hood. I can go ahead and continue ahead. So now we can see it's using NETCONF, that API that we talked about, to push out interface configurations that are there. These are in green because they happen to already be configured correctly. Now what's nice here is we learned about NC Client. Ansible is using NC Client to make these pieces. So if I ever needed to troubleshoot or add capabilities, because I understand the protocols, I can continue to use that and build inside of Ansible and contribute to the community as it goes. And so down here at the bottom, we can see that it's finished up. And on core 1, it was successful. It was able to finish and do what I asked it to do. Now, as we finish up, a couple other things that are worth going through. And so there's some tools under the hood that I've been using to go in. And the first one I want to talk about is viral utils. And so one of the things when you get into network programmability and automation, the question often comes up is, how do I test this stuff? How do I program against it? My boss is not going to let me go throw a bunch of network automation commands at our production environment. And so viral is a tool from Cisco that lets you build network simulations. You can build huge topologies that represent your real network and go through on that. We've had viral for a long time. It's heavily used for folks studying for their CCNA and NP and exams that are out there. Now what we wanted to do is, as I was looking at viral, I wanted a better way to manage that in a programmable fashion or a DevOps-like fashion. And that's where the idea behind viral utils came through. Has anybody heard of the tool Vagrant? Yep, I see a few heads nodding. So Vagrant's a command line tool for managing like VMs and containers for software developers. What I wanted is I wanted viral up. Right? I wanted to be able to very quickly bring up an entire network and manage it from the CLI. And so myself and a couple other SEs at Cisco came together and used the APIs from Viral and built viral utils to give us a Vagrant-like workflow. And so I'll show you what that looks like here. All right. Make this a little wider. So under the hood, my entire demo network that we run in these examples is actually running inside of Viral. And there is a GUI, there's a web interface, but if I'm living inside of my code, I don't want to have to work with that. And so I can simply go through here and say, viral nodes, tell me a little bit about what my network looks like. And I can see that I've got these devices running, a couple of core devices, distribution. I have some CSR devices and NXOS devices going through. And now from here, if I need to jump onto one of these devices, I can very easily go viral, telnet, access 1. And this will let me jump in and connect into that device that's there. And now I'm on that device, and it'll eventually prompt me for a password. Now, the way that viral utils works is similar to how Vagrant works, is we store a configuration file, a topology file, there it is, a topology file inside of our repository, where all my code is. And now this isn't a new topology file. This is the same topology file that if you've used viral already, this is what's being generated under the hood to describe your interfaces. By storing that file in my directory, I can then simply go through and I would viral up, and then it'll tell me it's already running. It would bring up this entire network, and I can go ahead and use it. I don't have to log in and launch these thick clients or abstract out of it. I can store my network topology for my sample code with my sample code. And so if you want to go look at the code that I ran in this example, this topology file is right there, and you could go ahead and bring up this entire network on your own and run these same examples, which is very helpful as I work with a team of network engineers. We can all work from the exact same file and leverage these tools that are there. The last tool I want to mention that's out there is, how many folks are network engineers? I assume most of the people that are here do some bit of network engineering. How do we test if the network is working? Ping, right? That's all we got. We ping from one side to the other. The last tool I want to mention is a tool called PyATS, which is a network test framework for actually testing real things across your network. This is mostly open source from Cisco, but it is 100% free. Parts of it are actually shipped as compiled binaries, but the vast majority of it is actually all open source pieces that are there. And you can pip install PyATS and then profile your network and start running tests like, how many BGP routes do I know about? How many BGP neighbors do I have? Do I have OSPF running? Like real good network test questions. And this is another completely written in Python program that you can start using immediately and get information. Now, if you're interested in any of the pieces that we went through, there's the review, and you're interested in more network automation, you can swing through. I'll be over at the DevNet table, which is over on Sponsor Row, chatting about kind of anything that folks are interested in. But we've also got resources like a video course that dives into network automation, shows you the fundamentals of using some of the stuff we talked about now, as well as other pieces. And then if you do have questions, feel free to contact me directly. My information's here, and I'll make sure it's available kind of in many places as I can. But you can reach me at hapresto@cisco.com or easily up on Twitter at hfpreston to go through. And Cisco DevNet is kind of the place to look for all of the information about what's going on in this space as it goes in. So with that, thank you so much for joining me for today's talk. And if you have any questions, we're out of time here, but I'll pack up, and then I'm just going to go around the hall, and I am more than willing to answer any questions that folks have. Thanks so much.